states of matter, gases and liquids. So first we will discuss what is the definition of matter. Matter is an object which having the particular amount of mass and it can occupy certain volume, then it can call as a matter. Now come to here, we have the states of matter. Generally, as we know, we have three states of matter, that is, one is called as a solid, second one is liquid, and third is called as a gas. Now let us discuss, for example, if we take one example, okay, then here why should we discuss that say states of matter means here, if we take the ice, okay, then water and water vapors are steam. Okay, here we have the three states of matter, that is, ice is present in the solid state, water is present in the liquid state, and here water vapors are steam are present in the gas states. Here if you see, even though having the different states of matter, here if we take the chemical formula of each state, chemical formula, here ice having the chemical formula H2O, water having the chemical formula H2O, and water vapors also having the chemical formula H2O. Means even though having the different states of matter, here same chemical formula. So what is the reason behind this means here, so what is the reason for the existing different states of matter means here generally we will consider two reasons. One is intermolecular forces first, and second one is thermal energy. So here we discussing, we have the three states of matters. One is solid, liquid, gas. If we take particular example, ice, water vapors, here even though having the three states are different, here the chemical formula H2O, what is the reason behind this existing three physical states means here we are considering the intermolecular forces and thermal energy. Now let us discuss how many types of intermolecular forces are there. Now intermolecular forces. Now what is the definition of intermolecular forces means? These are the forces of attraction and repulsion between, we should remember that inter means between interacting particles. Particles means we can take the atoms and molecules. Now intermolecular forces means what? These are the forces of attraction and repulsions. Forces we are going to include attraction and repulsion. Now here if we take now sum of attractive and repulsive forces, interaction forces are known as van der Waals forces. So van der Waals forces includes, it is a sum of attractive and repulsive interactions. Now, let us discuss how many types of van der Waals forces are there. Types of van der Waals forces. Now, here we have the three types of van der Waals forces. First one is dispersion forces. Dispersion forces are London forces. Second one is dipole forces. Third one is dipole induced dipole forces. Now, these are the three types of van der Waals forces are there. Let us discuss all the forces one by one. Dispersion forces are London forces. Second one is dipole forces. Third one is dipole induced dipole forces. Now, let us discuss first one. Dispersion forces are London forces. Now, these forces are first proposed by German physicist, that is called as a Fritz London. Hence, this name of this force is called as a London forces. Now, if you see what the speciality of these forces means, here these forces are exhibited by non-polar molecules because of the temporally correlated movement of electrons in interacting molecules. Means what? For example, if we take one example, here we have an atom A, another atom B. Here this is the nucleus of atom B. Around that we have the electron cloud. Here atom A nucleus, and around that we have the electron cloud. Now, this is a atom A, atom B. Now, in this case, what happened? We can observe the symmetrical distribution of electric charge or electric cloud. Next, if you say the second, in case of second one, here I am drawing another same atom, but there is a disturbance in the electron cloud. This is a atom A, and this one is atom B. So here we have atom A with instantaneous dipole. In this case, more electron density on the right hand side. Now, this is an atom with induced dipole. Now, so we are taking the two atoms A, atom with, when they are far away, when they are coming too close to each other, here we observe instantaneous dipole. Means what? Temporally. Here more electron cloud is present towards the right hand side. So once there is a when there is a dipole moments, mean there will be a attraction between these two atoms. This type of interactions called as a dispersion forces or London forces. Now, these are the temporary forces. Now, come to here. If you see, these are the energy. If you calculate, the interaction energy is inversely proportional to inversely proportional to the sixth power of the distance between the two interacting particles. Now, if you want what is the energy, how much energy is there, means that energy is inversely proportional to the distance. What is here r? R means here the distance between two particles, the distance between the two particles. So interaction energy is inversely proportional to the sixth power of the distance between the two interacting particles. Now these forces will act only at a short distance, that is around only 500 picometers. Next, here their magnitude, it means how much amount. The magnitude is depend on the polarizability of the particle. What is the meaning of polarizability? Means that is a nothing but creation of charges in a molecule is called as a polarizability. Dipole forces. So here the dipole forces act between the molecules possessing permanent dipole. So what is a permanent dipole mean? Let us take one example, HCl. Here if we take the HCl, in this molecule we have the permanent dipole. How? Why? Because means as we know very well, in HCl we have the polar covalent bond. Because of presence of polar covalent bond, we have the partial positive charge on hydrogen and partial negative charge on the chlorine. So this is molecule having the permanent dipole. So dipole forces act between the molecule. Now between the molecules possessing the permanent dipole. Now ends of the dipoles possess the partial charges. As you can see here on HCl, we are writing the partial charges. As you know very well, partial charges we are showing with the small Greek letters. Okay, complete charges you are not showing the complete, you are showing the complete positive, negative. Here we are showing the partial positive, partial negative. So ends of the dipoles possess a partial charges. Now what is the meaning of partial charges? Means the partial charges are always less than the 1 unit electric charge. As you know very well, 1 unit electric charge, how much? Electric charge is equal to 1.6 into 10 to the power of minus 19 coulombs. So the partial charge, the value of the partial charge is what? Always less than the 1 unit electric charge. Okay, next. Now if you see that if you compare the dispersion forces and dipole forces, the dipole forces are stronger than the dispersion forces or London forces. Next, if you see, the attractive forces decreases with increasing the distance between the dipoles. If you increase the distance, what happens? The interaction going to be decreases. If your distance decreases, the interaction going to be increases. Now come to the energy. Here we have the two types of molecules. One is stationary polar molecule. Stationary polar molecule. Another molecule we have rotating polar molecule. Rotating polar molecule. What is stationary polar molecules means? What? It is going to be very constant. That type of molecule called as stationary polar molecule. Rotating means it has some rotation. That type of molecules called as a rotating polar molecules. Now if you calculate the energy of these stationary polar molecules is inversely proportional to the r to the power of q. Now if you take the energy, if interacting energy between rotating polar molecule is proportional to the is proportional to the 1 by r to the power of 6. As we already discussed, r is the what? The distance between the two particles. The distance between the two particles. So yeah, here you have to remember permanent dipole. If molecule present permanent dipole, then only we have the dipole forces. Here we have the partial charges on the permanent dipole molecule. If you take the magnitude of permanent dipole charge, how much means that is less than 1.6 10 to the power minus 19 coulombs. Now if we calculate the interacting energy for the stationary polar molecule, that is directly proportional to 1 by r to the power of cube. If you calculate the interaction energy for rotating polar molecule is how much? That is directly proportional to 1 by r to the power of 6. Next we have dipole induced dipole forces. Now this type of attractive forces operate between the polar molecule between the polar molecules having permanent dipole and the molecule lacking permanent dipole permanent dipole means what's the meaning of that one? For example, if we take the molecule, here we have the molecule AB, okay, molecule having the two atoms, that is A and B. In this we have the permanent dipole, one is positive, one is partial positive, one is partial negative. Now this is a molecule having the permanent dipole. So it is a polar molecule. Now we have the another molecule, it is a non-polar molecule. Okay. Now so what happened when these molecules are interacting together? Now I am going to draw another diagram. Here A, B molecule possessing the permanent dipole, it is a polar molecule. Now when this molecule is coming close to the non-polar molecule, there will be a development of some charges here, partial positive, partial negative. It is now induced. Some dipole moment is what happened in this non-polar molecule is induced. So induced dipole in a non-polar molecule. So polar molecule having permanent dipole and the molecule lacking the permanent dipole. Now first what happened, this molecule having the permanent dipole, but this molecule is what, non-polar, but they are coming close to each other. What happened, this molecule which is having the permanent dipole induced the dipole moment in the non-polar molecule. So the type of interaction but present between these two molecules is called as what, dipole induced dipole forces. Mean non-polar non-polar molecule is induced by the permanent dipole to get the poles. That's what's called as what? Dipole induced dipole forces. Now come to the interaction energy. Interaction energy is proportional to the 1 by r to the power of 6, where already we discussed r is the distance between the two molecules. Now, induced dipole moments depends upon the dipole moment present in the permanent dipole and the polarizability of the electrically neutral molecule, means how much charges are developed, that is giving the strength of the dipole induced dipole forces. Next, thermal energy. What is the definition of thermal energy? Means thermal energy is the energy of a body arising from the motion of its atoms or molecules. Means whatever the atoms or molecules, while they are moving, they are getting some energy, that is called as a thermal energy. Now, this is directly proportional to temperature. Directly proportional to temperature. So what is the meaning of that one? Means once the temperature increases, thermal energy increases. Next, thermal energy, it is the measure of average kinetic energy of the particles of the matter, and it is responsible for the movement of particles. So you can calculate the average kinetic energy by taking the measurement of thermal energy. Now let us see how the thermal energy and intermolecular forces together get affect the particular phase or states of a matter. So already we discussed in our last class that states of matter, generally here we are considering the two factors. One is intermolecular forces and second one is thermal energy. Already we discussed the how many types of intermolecular forces are there. Now just now we discussed the thermal energy. Now how both are affecting the state of a matter. Now, how the intermolecular forces and thermal energy will affect the states of matter. Now, if you move from the gas to liquid, liquid to solid, here we can see the predominance of intermolecular forces. As we know very well, solid has the more intermolecular forces compared to liquid, and liquid has the more intermolecular forces compared to gas. Now, come to, if you see the thermal energy, now if you move from solid to liquid, liquid to gas, you can see the arrow mark from solid to gas here. Predominance of thermal energy means here what happened? Intermolecular forces tend to keep the molecules together, but thermal energy of the molecules tend to keep them apart. Now these are keeping together intermolecular forces, but thermal energy tend to keep them apart. Now come to the next. Here we have, so therefore states of matter are the result of balance between the intermolecular forces and thermal energy.